Okay, number 6 is asking us, summarize the history of the atomic idea. How was Dalton able to convince others to accept an idea that has been controversial for 2,000 years? So this one here is a very general question, and it's more so asking us the history behind the atom, basically. So again, uh, what this is again, when we go back to like the super early days with like the Greeks and whatnot, they thought that the atom here was the only thing that they've discovered is basically the atom is the smallest unit, right? And but they didn't know what we know now, right? Well, so a brief history of this is, you can think of it as the Greeks here, or sorry, oh, let me refresh this here. So let me zoom in here. So I have the Greeks here, or the basically ancient Greeks here. They thought that the atom was the smallest compound, right? Equals smallest particles. And they didn't really call it the atom. They just knew that it was the smallest particle. And we actually give them the word atom based off the Greeks, because atom is, I think the prefix here means small, right? And after that, Dalton here, the next kind of person to kind of break this theory was Dalton. And Dalton kind of what his kind of summarization of the atomic theory was that, Dalton stated that the atoms are the smallest particles. So they restated this here, but he also came up with this idea of he built on this idea of the law of conservation of mass and the law of multiple proportions. So when we're thinking of this problem here, we're thinking of, okay, so if I had, it's easier with an example. So I'm going to write down here a law of multiple proportions. And then he also, with Lavoisier, he also came up with the law of conservation of mass as well. But let's look at specifically the law of multiple proportions here. And what that is that when basically two different elements combine to form different compounds, like say here, the masses of one element with the constant mass of another element in different compounds are always related to each other here. So let's think of this problem here. If I have, again, hydrogen gas plus oxygen gas is going to give me water. So currently here on the left side, on the reactant side, I have two hydrogens, right? I have two hydrogens here and two oxygens here. And this side I have two hydrogens, but I only have one oxygen here. So in this case, this equation here does not obey my law of multiple proportions, because I have, again, the masses do not add up, right? I have two hydrogens and two oxygens. I have two hydrogens and one oxygen on this side here, right? So again, it's not going to add up. So therefore, what I need to do is I'm going to have to come up with a proportion between these two sides, right? And we know this as balancing chemical equations, right? So I would put a coefficient here of 2, which would change these values to, again, I have 4 hydrogens here and 2 oxygens here. And then on this side, if I want to have 4 here, I want to also put a 2 here to balance this out. Now, what I have here is a balanced chemical equation, and this here obeys the law of multiple proportions, and it actually also obeys the law of conservation of mass. Because again, mass here is neither created nor destroyed; it's simply transferred. And what we have here is law of multiple proportions, right? So the mass here of the reactants are the same as the mass of our products here. So again, it's only again, when two different elements combine to form different compounds, such as water, the masses of one element with a constant mass are always the same, are related to each other as a whole number. So in this case here, this is a 2, and this here is a 2 as well. So the solution here is correct. It's kind of incomplete, but I'm just going to give it to them here. Solution is correct. Dalton proposed the idea of the law of multiple proportions, and with Lavoisier, also contributed to the law of conservation of mass. Okay.